Um, Probably my writing won't be that sinking today because after a long time I've come back. So you have to adjust, right? Right. Are you able to see my screen? Whatever I'm writing?
Yes, sir, visible.
Right. So, what is basic definition of rectifier? Okay. So, if you see, like there are two types of currents or voltages, right? One is AC and one more is DC, correct? AC and DC, correct?
Yes,
Am I
sir.
right?
Yes, sir.
Right. So, AC means what is
Alternating
this?
currents.
Alternating current, correct? And DC, that is direct
Direct current.
current. So if you see the waveform alternating current, what does this mean? So if you see the waveform, so this is the waveform for alternating current, correct? So you have alternating cycles, positive and negative, positive, negative. So there are alternating cycles, that's why it is called as alternating current. Okay. So this is the time and this is the voltage or current. Okay, voltage or current, you can take anything. Okay, so this is alternating in nature. That's why it is called as alternating current. So if you see DC, okay, so let us say this is the zero level and this is the time period. Okay, so this DC can have both positive and negative voltages. Okay, now if I say DC means it is direct current. Okay, so say what does this mean? If you see, if you just compare AC and DC, please listen this carefully. If you just compare, you should pardon me, in between I might be coughing. Okay, you should pardon me for that. Okay, if you just compare this AC and DC, at all the points, at all the time period, if you take any time period, say for example at this point, okay, say for example at this point, what is the voltage? It is having some voltage, correct? And if you see at this point, okay, you have some voltage, and at this point you have zero, and say for example at this point, at this time period you have some voltage negative, and at this point you have some voltage which is peak negative. So if you see the AC voltage at a relevant time period, it is varying, it is not constant, correct? So it has, say for example, the voltage at this point might be, say for example, 2 volts. At this point it will be 3 volts. Again at this point it is 0 volt. At this point it is be minus 1 volt. At this point it will be minus 3 volt. Okay, so what I'm willing to say is the voltage is not constant for AC, it is varying, correct? Whereas for DC, you take at any point, okay, at any time, the voltage remains constant. Say at this time, what is the voltage? Say for example, this voltage is 3 volts, it remains constant throughout the time period. Okay, that is DC voltage. Okay, that is a major difference between alternating AC and DC. So the voltage or current remains constant for DC, whereas for alternating for AC, the voltage or current keeps on varying throughout the time period. Okay, that is a major difference between AC and DC, right? Understood? Shall we
Yes,
move
sir.
on further? Right.
Yes, sir.
So now what is rectifier? Okay, we need to know now, because we know the difference between AC and DC. Now we'll understand what is rectifier. So the rectifier is nothing but the circuit or the device which converts AC to DC. AC to DC is called rectifier. Understood? Yes, this is the major definition for rectifier. The device or the circuit which converts AC to DC is called rectifier. Any doubt?
No,
No,
sir.
sir.
No, sir.
Right. Now, let us see the types of rectifiers. Okay. Now, this is what we need to do. If I take the topic rectifier, then I need to convert AC to DC. That is what my aim is. Okay. Now, what are the types of rectifiers we have? Let us see that. So, first type of rectifier circuit is half-wave rectifier. Second type of circuit is full wave rectifier. In this, you have two types. In full wave rectifier, you have two types. Which are those? First one is two diode or center tap rectifier, and the second one is bridge rectifier. Bridge or four diode rectifier. Okay, so these are the types of rectifiers that you have. Okay, first one is half wave rectifier and the second one is full wave rectifier. In full wave rectifier, we need to study two more, that is two diode or center tap rectifier, and the other one is bridge or four diode rectifier. We'll start with half wave rectifier, which sir has done already. Half wave rectifier. Generally, we term it as HW. Okay, HW means half wave rectifier. Okay, now the circuit for this half wave rectifier is, okay, half wave rectifier. Okay. This is a resistor and this is a diode, right? This is diode D, load resistance RL, and this is the output V0. Output is taken across a resistor, correct? Always output will be taken across a resistor. Remember that. That is load resistor. This is V0. Okay, V0 means output voltage. Okay, so this is the circuit for half wave rectifier. Now, what you need to tell me is, what will be the input V in? What will be the input?
Alternative current, sir.
Yes, it is AC. V in will be AC. So can I write like this? Can I write like this? This is my input waveform, correct? Because it is alternating, correct?
Yes, sir.
Right,
Yes, sir.
right. Now we'll see the working of this circuit. How does it work? How does it does rectification? We'll see that. Now, during positive off cycle, we'll start with first one, that is positive off cycle. In positive off cycle, that is if input is input positive cycle, input is positive cycle. During input positive cycle, okay, during input positive cycle, what happens? Say input is positive cycle, okay. This is positive, this is negative, and this is positive. Okay. During positive cycle, what happens? Just if you see the diode, you know, like forward bias and reverse bias. Do you have that idea?
Yes, sir.
It
Yes,
is
sir.
forward bias, sir.
So during positive off cycle, the voltage is positive at, say for example, I'll call this as node A and I'll call this as node B. Okay, this is node A and this is node B. So node A is positive, correct? During I'll rewrite the circuit. Okay, right. During positive off cycle, so node A and node B, the same circuit I'm writing here. Okay, so node A is positive and node B is negative. Okay, this is RL. Okay, so once this voltage, once, because it is going positive, right? Once the voltage is increasing, once it reaches 0.3 for germanium and 0.7 for silicon, right? So if it reaches that breaking voltage or new voltage, what happens? This diode will start conducting, correct? This diode will start conducting. So I can write, then the diode behaves like a short circuit, correct? Then the diode behaves like a short circuit. Once the diode start conducting, the diode is treated as short circuit circuit. Okay? Are you understanding what I am saying?
Yes, sir.
Yes,
Right.
sir, getting.
Right. So then what happens? Whatever the input voltage is there, the output will be the same because the diode is forward biased. That means it is short circuited. So whatever input the positive cycle is there, in output you will get the same cycle as it is theoretically, but not practically. Practically, how does it look? Actually, the practically, this is theoretical. Okay, practically, how does it look? Is till 0.7 volts, there won't be any voltage. After 0.7 volts only, it starts conducting. Till 0.7 or 0.3, there won't be any voltage because till that the diode was not forward biased. If it is not forward biased, it acts like a open circuit. After 0.7 or 0.3, depending on silicon or germanium diode, it starts conducting. Okay, this is practical. Okay, but in exam and all, don't write this parameter. Don't write this. You write this only. Okay, this is just for your understanding. right? So during positive off cycle, the input is positive cycle, so the diode will start conducting. Since it is forward biased, why it is forward biased? Plus is connected to positive, that is p-type semiconductor, means positive polarity is connected to p-type semiconductor, and negative polarity, that is b, is connected to n-type semiconductor. That means it is forward biased. That's why once when it is forward biased, the diode acts like a short circuit. If it acts like a short circuit, whatever input is there, output will get the same, right? So this is during positive off cycle. Okay, we'll see during negative off cycle how does it behave. Now input is negative. So during negative off cycle, what happens? I'll rewrite the circuit. Okay. So you'll get diode here, and you have a resistance RL, and this is output V0. Okay. So now input is negative cycle. Input is negative cycle. So node A and node B. So node A will be negative and node B will be positive. So because of this, what happens to the diode? It acts like a, because negative terminal is connected to p-type semiconductor, so it is reverse biased. That's why it acts like a open circuit. Open circuit. It is not closed, so it acts like a open circuit. If it is open circuit, then will there be any output? Will there be any output? You don't get any output at the output. You don't get any output because the diode is open circuit. If you want to get any output, first the circuit should be closed. Then only we will get the output. Since the circuit is not completed, here you have open, so the current doesn't flow from input to output because it is open. That's why you don't get any output at the across the resistor. So if I generalize this input and if I generalize this positive cycle and negative cycle, I can write the waveform something like this. So you have a positive cycle and negative cycle, positive cycle, negative cycle keeps on going, positive, negative, negative, right? In the output, if you see, this is an output V0, this is V in, okay? Right. So for positive off cycle, what we got? Positive off cycle as it is, because the diode is forward biased. So the positive cycle comes as it is at the output. During negative off cycle, we are not getting any output. That's why there is no output during negative off cycle. That's why it is 0. Again, during positive off cycle, we will get the same input as it is at the output. And during negative off cycle, we don't get any output. So this is the output waveform for half wave rectifier. That's why only half of the wave is coming at the output. That's why it is called as half wave rectifier. Okay, understood? Any doubt in this explanation?
No, sir.
Right. So this is about half wave rectifier. We will see now. In the beginning, what I told, a rectifier converts AC to DC. If you see this waveform, can you make it out whether the output is DC. Is it DC, completely DC, or partially DC? As this aware rectifier converted the AC current to DC current, as it converted, it has not converted fully DC. Output is not fully DC, it is partial DC. That means it has both AC as well as DC component. So how much AC component is there, how much DC component is there? So for this all we have expressions, because if you see the DC, how DC should look? It should look like this, right? Constant voltage, correct? But if you see here the output, it is not constant like this, correct? So it is having still ripples, it is having still spikes or ripples. So that is nothing but it is not complete DC, it is having both AC and DC. So for that we need to do some more advancement in the circuit in order to completely convert to DC component. So that is nothing but further advancement will come in the circuit, that we will see later. As of now, this is the output of a rectifier. So of a rectifier doesn't convert the AC current or voltage into fully DC current or voltage. It partially converts but not fully. If you see, only half of the input is been converted, correct? Only positive cycle is been converted, whereas negative cycle we are getting 0. So that's why it is called as half wave rectifier. Okay, now we'll see, this is first we'll see all the circuit explanations, and then we'll start deriving the expressions, because you need to understand first what is half wave rectifier, full wave rectifier, then expressions are derivations will be quite easier to do. Okay, this is all about half wave rectifier. Any doubt in this? Yes, someone should respond so that I'll move on.
No, sir.
No,
Right.
sir.
No, sir.
Yes, we'll move on to full wave rectifier now. Okay. Second type is full wave in that A, because there are two types of full wave rectifier circuit. In that first one, I'll go with two diode full wave rectifier. Okay, in this we have two types. So first one is two diode or center tap full wave rectifier, and the second one is four diode or bridge full wave rectifier. So first we'll see two diode or center tap full wave rectifier. Okay, I'll just draw the circuit. This is the center transformer primary winding, and this is very important. Okay, this is very important in writing. Can you see? In the secondary, we have two separate windings. Okay, so this is primary winding and this is secondary winding. Okay, now if you see, what does this mean? Anyhow, during explanation I'll do that. So you have diode, and you have diode here, and this is one load resistor RL, diode D1, diode D2, right? So you have step down transformer. We have to use step down transformer only in this circuit, even in case of off rectifier also. Okay, even in off rectifier also. Okay, if you want to mention here, you can mention the transformer, because that is step down transformer we are going to use here. What does the step down transformer does? It converts high voltages into low voltages, correct? So because our AC mains has 230 volts, correct? It ranges from 230 to 400 volts. So the diode need to operate in the range of very less voltages, not more voltages, depending on the need. Okay, so we need to convert that high voltage into low voltage. That's why we use step down transformer. So this type of transformer is called center tap transformer. The transformer that has to be used here will be something like this. In case of off rectifier, I'll just show you how to use. If you want to use a transformer, you can use something like this. This is secondary winding, and this will be primary winding. So you have voltage here, V in AC voltage. So that is 230 volts, very high voltage will be having. So you can mention here 230 volts. So here in the secondary winding, similar, but the voltage is less. You can mention here, say for example, it is also AC voltage. Okay, it is also AC, but the voltage is less. Say for example, depending on the number of turns, N1 and N2 ratio, say for example, I can reduce, for example, this is just for example, it can be of 12 volts. So it has, this transformer has reduced from 230 volts to 12 volts. Okay, so this is normal transformer, step down transformer, just step down transformer. Okay, similarly, in case of center tap, you can see the difference. Here, in the normal transformer, you don't have any center tapping in the secondary winding, whereas here you have center tapping here. This is the key feature of this. You have center tapping in the secondary winding. So, what does this center tapping transformer does? That you need to understand first. So the same voltage, that is AC, the input will be AC input with 230 volts. Okay, and you have 230 volts AC input. Okay, here what happens in center tap transformer? Say for example, this is also AC. Okay, because of this, N2 windings are very less. From here to here, the windings will be calculated. Okay, say I'll be down converting it to 12 volts. So the waveform will look something like this, similar. Okay, this is from this point to the center tap point to here. Similarly, from center tap point to downward, because we have one more winding here. So what happens? The same replica of this voltage will be here. That is AC. It is also AC. Again 12 volts, and the voltage is similar. Same replica. If it is positive, here also it will be positive. Here if it is negative, here also it will be negative. Same replica. Two waveforms will be available for the center tap transformer. This is the major working of this center tap transformer. Application of this center tap transformer. Okay. So now what we'll do, we'll see the operation of this circuit. We'll see the operation of this circuit. Say I'll call this point as 0. I'll call this node as 0. I'll call this node as A, this node, and I'll call this node as B. Okay. Now, please, you should not miss any point here, whatever I'm saying. Okay. So during positive off cycle, similarly, as we explained for off wave rectifier, we'll start with for full wave rectifier also. So for positive off cycle, positive input is input positive okay, input is input positive cycle. What happens? You should tell me. During positive off cycle, I'll rewrite the circuit. Okay. This is node A. This is load resistance. This is node B. Right. So this is RL as it is. Now during positive off cycle, this is positive, and here also it is positive. I said you, it is replica voltages, correct? Whatever voltage is here, the same voltage will be there for this secondary winding, down secondary winding. Okay. So if it is positive, this is also positive. Okay, this is 0, this is node A, and this is node B. So for positive off cycle, what will be the node A? Will it be positive plus? Correct? Am I correct? For positive off cycle, node A will be plus.
Yes, sir.
Yes, sir, correct.
This will, that 0 will be negative. If it is positive, obviously this should be 0 negative. 0 node will be negative. This is 0 node. Center tap node is 0. I have named this node as 0 or O, something like that. Whatever you can give the name, you can give. So this center tap node will be negative towards upper side. Am I right? Yes?
Yes, sir.
And similarly here, so it is also positive. The node, center tap node will be positive, and this will be negative. Am I right? Node B will be negative downside, this loop. So center tap node downward will be positive, and node B will be negative. Am I right? For positive cycle, the downside loop.
Yeah, yes, sir.
Correct? Now tell me which diode is forward bias and which diode is reverse bias.
Sir, D1 is forward biased and D2 is reverse biased.
Exactly. Since the positive terminal is connected to, if A is positive, see here, if A is positive, this positive terminal is connected to P type. That means diode D1 is forward bias. If D1 is forward bias, the circuit I can replace it by short circuit, correct? I can replace it by short circuit. Similarly, what will be diode D2? It is reverse bias because the negative polarity is connected to P-type semiconductor. That's why diode D2 will be reverse bias. So it is reverse bias. That's why it acts like a open circuit. So now the current will start flowing from node A. Please understand this. The current will start flowing from node A, something like this, and completes at center tap. So this is current direction. So if this is in current direction, obviously the output across this load, resistor RL will be what? Positive cycle, because whatever input is coming, output will be there. Whatever this input is there, the same will be there at the output. The same will be there at the output. Correct? Any doubt in this? Any doubt?
No, sir.
No, sir.
Right. So this is for positive off cycle, because if you see the downward, okay, if you see the down loop, since it is open circuit, obviously there won't be any current in the loop. So you have to neglect that. Okay. Now we'll see for negative off cycle. How does it work? Input is negative cycle. Okay, the same circuit again I'll rewrite it. This is RL, okay, diode D1, diode G2, right? So now input is negative, that is input is negative cycle. I'll write negative cycle, obviously this also will be negative cycle, right? So now node A, node O and node B. Can you tell what will be node A? Node A will be
Negative.
side will be negative and node B will be positive, correct? Am I right?
Yes, sir.
Right. So once you give this designations, now it will be easy for us to decide which diode is forward bias and which diode is reverse bias. Now can you tell which diode is forward bias?
D2, sir.
D?
Sir, D2 is forward bias and D1 is reverse bias.
Correct. D1 is reverse bias, so I can write this as open circuit, and D2 is forward bias, so I can close it. It acts like a closed circuit. Now what happens? The current will start flowing from B node, that is positive node, and it completes at center tap. This is current direction. This is current direction. Okay. Now what you need to understand is, can you see the current direction for positive cycle and negative cycle in the load resistance? It is moving from right to left. It is moving towards the load, that is center tap. in both the cases? Means I am telling the current direction for both positive cycle and negative cycle in the load resistance is in this direction only. Correct? In the same direction. This point is very important. Please understand, the current direction in this load resistance, this is the load resistance. Okay? So in this load resistance, in case of positive cycle, is from right to left, that is in this direction. Correct? And in negative cycle also it is from right to left. Can you see? It is from right, the current direction is from right to left. It is moving from this, from the right to left. Correct? Are you getting what I am saying? Yes?
Yes, sir.
So with this I can write, so if the current direction in case of positive cycle is from right to left, if I'm representing the output something like in positive cycle, obviously for negative cycle also the output will be positive cycle only. This is very important. The output will be positive cycle only. Even the input is negative cycle, even though the input is negative cycle, the output will be positive cycle. This is what you need to understand. Because the current direction in case of positive cycle is also from right to left, that is towards the center tap node. In case of negative cycle also, the current direction is from right to left, that is towards the center tap node. So that's why it is, the negative cycle is becoming positive cycle, because current directions are same in case of positive cycle and negative cycle in the load resistance. Understood? Yes? If you say yes, I'll proceed. Or if you have not yet understood, we'll do it once again.
Sir,
Ah,
why we use transformer, sir?
because the input is, in your home, if you have a plug,
Yes, sir.
what is the input you will get there? It will be 230 volts.
Yes, sir. 50 hertz.
Yes, 230 volts and 50 hertz, correct?
Yes, sir.
So directly if you give that to a diode,
Mhm.
what happens? It will
Yes,
burn.
sir. Yes, sir. Because it cannot handle that much.
Yes, it can't handle. So for that reason, we are using step down transformer.
Yes, sir.
Got it?
Yes, sir.
Right. So have you understood this circuit? How does it operate in positive cycle and negative cycle? So if I consolidate the waveform, it looks like, I'll write here, okay, for that output waveform. Okay, so this is my input V in. Okay, so it will be positive cycle and negative cycle, positive, negative, positive, negative. And if you see the output waveform, V out, okay, for positive cycle it is positive, for negative cycle also it is positive, for negative cycle also it is positive. Why positive? Because the current direction in the load resistance is in the same direction as positive cycle, that's why it is positive. In positive cycle it is positive, in negative cycle also it is positive with same amplitude, with same peak voltage. Okay, this is, so you can see that, that's why it is called as full wave rectifier. Both the cycles, positive cycle as well as negative cycle, are being rectified. In case of positive half wave rectifier, only half of the wave is been coming at the output, whereas in full wave rectifier it is not so. We are getting both the cycles at the output. Positive cycle as positive cycle, negative cycle is converted to positive cycle at the output. Okay. Understood? That's why it is called as full wave rectifier. Clear?
Yes, sir.
So this is about two diodes. How many diodes we are using? We are using two diodes. That's why it is called as two diode model, or it is called as center tap because we are using center tap transformer. Because we are using center tap transformer. That's why it is called as two. Sometimes they may ask like explain two diode full wave rectifier. Then you have to write the circuit and explain the positive cycle and negative cycle, and you have to show very clearly the current directions in the load resistance. Okay. Similarly, if they ask center tap transformer full wave rectifier, the answer is same. Okay, they may ask any way. So this is all about two diode or center tap full wave rectifier. Okay. So with this, uh, we'll wind up the class for today. And if you have any doubts, you can ask me. I'll clarify. With respect to half wave rectifier and two diode center tap rectifier. If you want me to explain this once again, we'll do that in tomorrow's class, because this is very important topic for exam. They will ask either half wave rectifier or full wave rectifier or related expressions out of this. There are some derivations related to this half wave rectifier and full wave rectifier. 100% they'll ask from this topic. See, this is what it is. Okay. I'll just briefly explain. Okay. Half wave rectifier circuit. This is half wave rectifier circuit, right? You have 230 volts. Okay. And it is an AC input. This is secondary. This is VP means voltage primary. That is nothing but V1. Voltage secondary. VS means voltage secondary. I call it as V2 voltage. Okay. So this is the circuit for half wave rectifier. So during positive off cycle, so this is the input as positive cycle. So this terminal is positive, this terminal is negative. Similarly, node A is positive, node B is negative. Step down, here it has been step down. Okay. So node A is positive, node B is negative. So because of this, plus is connected to p-type semiconductor of diode. That's why diode D is forward bias, so it acts like a closed circuit. So current will start flowing in this direction from positive terminal to negative terminal. So thus the output at the across the load resistance RL. Whatever input is there, the output will be same. So this is for positive cycle. During negative off cycle, so this is negative off cycle at the input. Because of this, node A will be negative and node B will be positive. Okay. So if node A is positive, obviously because diode p-type is connected to negative terminal, so it is reverse bias. That's why it acts like a open circuit. That's why we don't get any voltage at the output. Okay, this is for positive cycle and negative cycle. If you consolidate, the waveform looks like this. Only during positive off cycle we'll get the output. During negative off cycle we don't get the output. That's why it is only half of the waveform is been rectified. That's why it is called as half wave rectifier. Okay. The another half, that is negative cycle, it is not rectifying. That's why the one half is not rectifying, only one half is rectifying. That's why it is called as half wave rectifier. Okay. This is all about half wave rectifier. Then coming to full wave rectifier. So I said there are two types. The first one is center tap. You can see the circuit for this. There are two diodes and it is center tapped. Okay, that is the upper one voltage is Vs1, the lower one voltage is Vs2, that is secondary voltage 2 and secondary voltage 1. Vs1 is nothing but secondary voltage 1, this Vs2 means secondary voltage 2. So when the voltage, I mean when the input is positive cycle, when the input is positive cycle, what happens? So they are not mentioned here. Okay, when the input is positive cycle, what happens? So you get positive wave here. Okay, similarly you will get positive wave here. Okay, because of this, so node A will be positive and this center tap I'll call it as 0. So the upper portion, that Vs1, the from center tap upper portion will be negative, the lower portion will be positive and node B will be negative. With this the terminology, terminals, we can decide which diode is forward bias and which diode is reverse bias. So with this, you can, node A is positive, so diode D1 will be forward bias, node B is negative, diode D2 will be reverse bias, D1 will be forward bias. Because of this, the voltage will start, I mean the current will start flowing from node A to the center tap transformer. Okay, center tap point. So the current direction will be in this way. That is, it is moving in this way towards center tap node. So this is during positive off cycle. That's why you will get positive cycle across the load. Similarly, during negative off cycle, the same parameter, because node B will be positive and node A will be negative. So similarly, at the center tap, you can designate the nodes something like this, plus and minus. And what happens? The current, because node B is positive, diode D2 will be forward bias and diode D1 will be reverse bias because node A is negative. Because of this, the current will start flowing from positive terminal towards the center tap node. So if you observe the current direction in the load resistance for positive cycle, it will be for the negative cycle also it will be in the same direction, that is from right to left, that is from right to center of a center tap node. That's why the negative cycle will be converted to positive cycle at the output. If you consolidate, the waveform looks like this, that is positive cycle, positive waveform at the output, negative cycle, it is converted to positive of positive wave. That's why it is called as full wave rectifier, because both the waves, both the positive and negative waves are being converted to are being rectified at the output. That's why it is called as full wave rectifier. For today, we'll stop here and tomorrow we'll continue with bridge full wave rectifier. Right? Shall we stop here? Shall we stop here?
Yes, sir.